on to number 4. This is part 2 of lesson 14. I don't know where we are. All right, so I've got one logarithm here, so I need to write that as an exponential equation. So that becomes 2 to the 57th power is equal to 5x plus 7 to the 19th power, and that's awful, right? That is awful because, hey, 5x plus 7 to the 19th power, that's 5x plus 7 times 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 7. Right? There's a lot of them. I don't want to deal with that. That sounds terrible, right? But remember the trick that we took out here was we took the 5th root. We saw that 15 and 5 are both divisible by 5. It turns out that both 19 and 57 are divisible by 19. So what I'm going to do is take the 19th root of both sides. What's that going to do? Well, let's write them as exponents and it'll be clear. So this becomes 2 to the 57th power to the 1/19th power. And this becomes 5x plus 7 to the 19th power to the 1/19th power, right? Let's go ahead and multiply those exponents. 57 times 1/19 is the same thing as dividing 57 times 9 by 19. Dividing 57 by 19. So that turns out to be 3. So that's 2 to the 3rd power. 19 divided by 19 is 1. So I was able to break that out of its parentheses. That is awesome. Awesome. I broke that thing out like El Chapo. See, Sam? All right, so this becomes 8 equals 5x plus 7. I'm going to go ahead and subtract 7 from both sides. So I get 1 equals 5x. Divide both sides by 5. I'm going to get that x is equal to 1/3. I'll split that out. Hey, once we get that answer, we got to check it, right? Make sure that we don't have the log of a negative number or the log of 0. And so just imagine if I put 1/5 in there, right? 5 times 1/5 is 1, right? 1 plus 7 is 8, so we're good to go. Right? Awesome. Let's do another one. So let's get number 3 done. It has already been written with one logarithm, so let's go ahead and write that as an exponential equation. Or in terms of exponents, rather. So this is log base 10, remember? If there's no base, it's assumed your base is 10. So let's write that as 10 to the 4th power equals 2x plus 5 squared. And now, you know what I would rather do? Because right, this says 2x plus 5 times 2x plus 5. And I could multiply that out. And I could set that equal to, what, 10 to the 4th power. But you know what? That's too much work. We could just go ahead and take the second root of both sides, or the square root of both sides, and then I can get rid of this exponent right here. This one. I want to get rid of that exponent. And remember, right, if I don't put a number there, it means the square root, just like if I don't have a number in my log base, it means log base 10. So again, this becomes 10 to the 4 to the 1/2 power, and this becomes 2x plus 5 squared to the 1/2 power. Okay. I'll just multiply it out. I didn't do that with the other ones. Maybe that's a skip step that I shouldn't skip. But that becomes 4 over 2, right? And this one becomes 2x plus 5. So that's 2 over 2. Right? And multiply the exponent. So this is 10 squared equals, well, that's 1, right? So that breaks it out of parentheses, right? Because 2x plus 5. So the first power is just 2x plus 5. So now, I'll write this as 100. Subtract 5 from both sides. And then divide both sides by 2. And let's go ahead and leave our answer as 95 over 2 because, I mean, you could write it as a decimal, but that's a great answer, right? Can't be simplified. That's awesome. I like this answer. Now let's check it. If we put 95 over 2 in our original equation, so if we substitute that in for this x, do we wind up with a negative number inside of our log, or 0? No. So I'm going to go ahead and say, oh, and this one we checked, right? All right, moving right along, singing our basic song. Okay, so now we have 2 logs, and remember that our first step is to write it as a single logarithm, right? Yeah, we'll skip this one and get to the ones that are actually in your book, which are right here. Here we go. All right, so we'll go ahead and skip that one. We'll go right to 5. This one's in your module. First thing we're going to have to do is write it as a single logarithm. So here we go. It's about to get real complicated. I'm not sure what this is doing. Okay. So if I write this as a single log, this becomes log of x squared plus 7x plus 12 over x plus 4 equals 0. You guys remember? I'm using the property that tells me that if I have log of x, logs? With my bagel, yes please. No. If I have log of x minus log of y, that's log of x over y. So I'm applying that property to something a little more complicated, right? So what does this say? Well, we do have it just as one log, right? We have one log, so let's go ahead and write it as its exponential equation counterpart. which tells me that this stuff inside of my log base 10 is equal to, right, remember there's a 10 there, 10 to the 0 power, which is 1. I'm going to have to rewrite this over here, but I'm going to make that 10 to the 0, 1, and I'm going to switch sides. And actually, hey, I think maybe this problem will be a lot easier if I factor. I see a quadratic. What's the first thing I want to do? Is factor. So I got to remember factoring way back from last semester. I got to think of two numbers that if I multiply them together, I get 12, but if I add them, I get 7. How about 4 and 3? So this is x plus 4 times x plus 3 all over x plus 4. Hey, that's nice. Why? No things cancel. Like your schnazzle. Okay, so I'll subtract 3 from both sides. And I get that x is negative 2. I have to check to see if I have an extraneous solution though. So let's do that. So first of all, if I put negative 2 in here, I'm good to go, right? I wind up with a positive 2, so no problem, right? I gotta check this one. Is it the case that negative 2 squared plus 7 times negative 2 plus 12, is it negative or is it 0? Let's see. It's negative 14 plus 12 is negative 2, and negative 2 squared is 4. Negative 2 plus 4 is 2, right? So then it checks. Right? We said that this is equal to 2, so we're good to go. Is that right? I better double check that. Yes. That was probably about as complicated as they get. Yeah. Let's do another one. Another one. Oh. Sorry, I'll give you the answer. You don't need the answer. Here we go. All right, first thing I need to do is write this as a single logarithm. 3x times 4 is equal to 4. There we go. I'm going to go ahead and multiply those things together and call that 12x equal to 4. Let's write it as an exponential equation. 2 to the 4 power is equal to 12x. 2 to the 4th power is 16. Divide both sides by 12. And we get that x is 16/12. But that means that x is, and those are both divisible by 4. So that's 4/3. Hey, if I plug 4/3 in there, do I get 0 or a negative number? It's going to be positive, right? I'm not sure why they put a really hard problem and then a really easy problem, right? Let's do this one, which is, I think, a little bit kind of in the middle. Remember that when we are condensing logarithms, when we're putting them, or we're going to write them as one logarithm, we got to take this 2 and bring it inside first, right? As an exponent. So this is going to become natural log of x plus 2 squared, okay? That's what we did with that 2 on the outside. And this is negative natural log of negative x. All right. Let's go ahead and write it as 1 log. So this is going to become natural log of x plus 2 squared over negative x equals 0. Now we will write its exponential counterpart. And remember, natural log, or ln, is log base e. So that means that, I know, there's no point to this pocket. It's the weirdest thing. Don't do that, sorry. I was tired.
That roll is like it.
Huh? I thought it was you. No, you're staring at me. I thought we were looking at the pocket. Like, I don't know what makes you look at. You're right. Alright, so that means that I can write this as e to the 0 equals x plus 2 squared over negative x. So that means that 1 is equal to x plus 2 squared, right? Because anything to the 0 power is 1. I'm going to go ahead and write this back up here because I'm running out of space. I'll just rewrite the problem up here. Just rewrite where we're at. Hey! I think what I should probably do is multiply both sides by negative x. That way I'll get that negative x out of my denominator.
Just one thing, turn southern.
Nobody wants to have to roll this one with text and everything.
You're right about that.
So I'm going to go ahead and do that. Negative x. So I get the negative x is equal to, right? And the whole point was those were going to cancel because that turns out to be 1. Darn it! I really wanted to avoid multiplying this thing out, right? But it's unavoidable. I'm going to write this in between step out here. This problem has very, very, very many steps. Doesn't it? It's like going to the top of a tall building. So x times x is x squared. X times 2 is 2x. 2x times 2x is 2x. And 2 times 2 is 4. Let's go ahead and simplify this thing. And now again, it looks like I got a quadratic, so what should be on one side of my equal sign? What should be on one side of my equal sign? Thank you. Not area. I almost died. How will I make that happen? Alright, so then now I have 0 is equal to x squared plus 3x plus 4. And hey, we're back to all that wonderful stuff we learned in first semester and that you have learned in Algebra 1, let's be honest. Or you should have. So hey, you have, you can factor, or you can use the quadratic formula, right? Factoring, in my opinion, is the easier way to do it, because all I have to do is think of two numbers, that if I multiply them, I get 4, but if I add them, I get 3. Wait. Ouch. That sucks. Yeah, that does not work, right? There are no two numbers that do that. Because 4 and 1 would be great if this was negative, right? If this was a negative 4, I could use 4 and 1 because I could do positive 4 and negative 1, right? Positive 4 and negative 1 add to 3. But darn it, they're both positive. So it looks like...
It looks like you should have added x to both sides and not 5.
Oh, you know what? Here, this is my kid. Thank you.
And when you get 5x, you're going to do 1.
Hey, no, it's factorable. Thanks for that. You saved our lives just now. I take back everything I said about you. I take too much. So that means that our two solutions are x equals negative 4 and x equals negative 1. Well, what do we have to do? We have to check it. Dang, that was a long problem. Alright. What happens if I put negative 4 in here? Uh-oh, SpaghettiOs. Negative 4 plus 2 is negative 2. So this one is extraneous. How about negative 1? If I plug negative 1 in here, I do believe that works out, right? Cool. How about if I plug negative 1 in here? Negative 1 is positive 1, right? So negative 1 checks out. Is our only solution.
Why does negative 1 work?
Because, right, imagine this right here is negative 4. Then negative 4 plus 2 is negative 2.
Oh, it's a negative.
And you can't have a negative number inside of your logarithm. Alright. Let's do another one. Uh-oh, what? This doesn't look like the other ones we did. Oh, come on. So remember what I said. You need to either have one logarithm on one side of your equal sign and a number on the other side, or you could have one logarithm and only that logarithm, and then another logarithm on your on the other side of equal sign. I need to make that look like one of those two cases. So what I really need to do is get this over to the left-hand side. I need to get log x to the left-hand side. How do I do that? I add it to both sides, right? Okay, so I'm going to write then that this is log x plus log x equals 2, right? From here, I can use two approaches, okay? I could say that that is log of x times x, right? Yeah? That's also 2 log x, isn't it? If I have 1 log x and I add another one, I have 2 log x's. Either way works. It turns out that using your addition property is actually going to be fast. So let's do that. Let's do it faster. I want to go fast. 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 Okay.
We're going to do it.
Now let's go ahead and write it as an exponential equation. I'm going to do that up here. So that's going to be 10 to the second power. It's going to be equal to x squared.
Now you gotta shorthand shit.
So that's going to be 100 equal to x squared.
Hell yeah, brother.
Hey, if I don't have an x term in here, right, I could just go ahead and take the square root of both sides. That's going to give me a correct answer.
It's really not.
Yeah, every time. So if I take the square root of both sides, I need to consider that this is going to be positive, plus or negative, plus or minus, square root of 100 equals 100 equals x, right? So that if I take the square root of x squared, it's just x. And the square root of 100 is 10 every day. So that means that I got two solutions. I got x equals to 10, and x is equal to negative 10. You go back and check those, and it looks like negative 10 is a bunch of malarkey.
Malarkey?
It's Boulder Dash, you know what I'm saying?
Boulder Dash.
It's when English people call it, they say poppycock.
Oh yeah.
What in tarnation?
Yeah.
I'm just trying to talk like one of them formal people from the United Kingdom.
Yeah.
It's okay. You don't have to be all mad because America beat you. It's been hundreds of years.
100 years, dude.
So then this is our only answer.
Bitch.
Okay, let's do this next one for America.
For America.
Yeah.
Behind that.
I'd say maybe we walk away from it, but these colors don't run. Okay. With this one, I have no number in there, right? We used to have some numbers. I don't have any numbers, so it looks like this is going to be the case where I have a logarithm on one side equal to a logarithm on the other side, right? Okay. So first thing I need to do is I need to make this stuff over here on the right-hand side into a single logarithm. So I will go ahead and make it a quotient. There you go. I could have added x plus 3, the natural log, I should say, x plus 3 on both sides. We get the same answer. Now, hey, if I raise everything to the e power, essentially, right, if I put these as powers of e, they're going to go away. But how about this? If you got a log on both sides, you got the log with the same base on the other side, right? It turns out that we can just drop these. We can drop these logarithms away and just solve for this, right? Same way that we did with our exponential equations, right? I want to know what value of x I put in here and in here that makes the insides of these the same, right? If the insides are the same, then the equation is the same. So I'm just going to drop it out. Like that boy that your mama don't want you to date.
Oh, yeah. Yeah.
So you just canceled the
Yep.
Stop.
So now I don't want that x plus 3 in there anymore. So how do I get rid of it? I multiply both sides by x plus 3. That means I got to do some foiling over here, and I ain't talking about the kind you get when you get dye, when you get your color done over there.
When you get to die.
I ain't talking about the foil you use when you get a color. I'm talking about foil like math-wise. Those canceled? I wind up with x squared. Plus 5x plus 6 equals 12. Oh, it looks like I got a quadratic equation again. Which means I am going to have to subtract 12 from both sides. so that I can have a 0 on one of my sides. You want a 0 on one side like that one time? You used a girl who wasn't good enough for you?
Oh.
Okay, I can factor this. That's going to be -1 and +6. So my answers are 1 and -6, but I got to check them. If I put -6 in here, that is where my trouble is, right? If I plug -6 in there, I wind up with -6 plus 2, which is -4, and I have a log of a negative number. If it doesn't work in one of them, it just doesn't work. But we got to check number 1. We got to check them all, okay? So if I put 1 in here, we're good. This becomes 3. If I put 1 in here, if I put 1 in there, we're good, because I just get 4. So 1 checks. And that is our only answer. And we have now completed lesson 14. Thank you very much for flying Dorman Airlines. All right.